Good morning. This is the first lesson after we finish the major news broadcast project. This is Unit 5, Student Activity Sheet 1. In this the end of this marking period and the beginning of the next, we'll be working on two units, Unit 5, which is Functions and Models, and Unit 4, which is Recursion and Models. Recursion is a new thing. We'll be switching in between the two units because they correlate very well together. As a matter of fact, the assignments look almost identical, except we're looking at it from two different perspectives. And it's good to do them together so you can see both perspectives at the same time. So let's look at the bell ringer. Take a moment and estimate your arm span with the yardstick. How does that measure up to your height? Okay, so I measured mine, and my arm span from the middle of my chest to the tip of my fingers is 36 inches. So arm span is from tip of the fingers to tip of the fingers, so that's 2 yardsticks, or 72 inches. I also happen to be 72 inches tall. And actually, I'm actually only 71 inches. I'm 71 and a half. So my arm span is longer than my height, just by a little bit. And it's kind of strange. You'll see later on in this particular video why that correlation is important. So the ratio of my arm span to my height, if I want to look at it carefully, that is 72 divided by 71. It's 1.01 or 1.02. So I have a little bit longer arm span than I do my height. Is there a correlation between your ratio and any of your classmates? Well, while I don't have the opportunity to look, I would venture to say that the majority of the people in my class, or majority of the students in my class, are probably going to have about the same arm span as their height. So in 2008, U.S. Olympic swimmer Michael Phelps broke the world record for winning the most gold medals at a single Olympics with 8. And in that year, in 2008, he held 32 world records in swimming. As a competition swimmer, Michael Phelps was I wouldn't say that at the time, he came after my swimming career was over. But, I mean, I still followed him. He's a really good swimmer. But do you know who he beat out of the record? The person before him that held 7 Olympic gold medals in one Olympics was also a swimmer, and he was a multi-swimmer just like Michael Phelps, and he held a lot of world records at the time, and that's Mark Spitz from the 1976 Olympics. So that's 32 years that he held that record, 7 Olympic gold medals in one Olympics. So there you go. What do you notice different about Michael Phelps? It's different from most people. Most people, we said, have an arm span to height ratio of 1. You notice how long his arms are? If you put your arms down, they probably go down about the same length as him, but he's got a really long torso. And because of that long torso, it makes his arm length really long too. One factor that talent scouts look for in potentially competitive swimmers is the ratio of their height to their arm span. Most people, arm span is generally equal to the height, or it's a 1-to-1 ratio. But Michael Phelps, who's 6 foot 4 inches tall, has an arm span of 6 feet 7 inches. That's a 3-inch difference. In fact, the U.S. swim team found that its male swimmers have an average of 187.1 centimeters and our average arm span of 192.9 centimeters. That's 5.8 centimeters difference. Now, of course, other factors influence the success of swimmers, but coaches often look at a swimmer's physical attributes, specifically in swimming, arm span, to determine which stroke he or she could focus on. All right, so at a local competitive swim club, the coach measured the height and arm span of his top 10 swimmers. We're going to enter the table into a graphing calculator, and we'll sketch the graph it makes and describe it in words, okay? We won't have to sketch it because it's right here. I'll clear this out here. Let's see. Stat, enter. We're going to enter into this. Let me clear this out. I realized it was still full. Okay, so the first height, 172. 173, 179, 180, 183, 187, 190, 191, and 192. So we should have 10 items. Let's move over to L2. Height is the centimeters in column L1, and in L2 we'll put arm span, 173 or 175, 182, 185, 187, 189, 186, 195, 191, and 196. Okay, how do we look at this? What do we need to do with this? It says, enter the DAF and sketch the graph it makes and describe it. So we're going to correlate this by first of all, we got to turn on our stat plot by going second, y equals. We'll turn this on, hit enter, and we're going to turn it on. Notice the cursor's blinking on you, hit enter, and now it's on. And we want it to be a, let's make it this is a line plot, or we can make it a scatter plot. What did it ask us to make? It says sketch the graph and makes and describe it in words. Okay, so let's enter this, and if you hit zoom, it's going to tell you, you're going to put this exactly the way it wants. So zoom stat or zoom 9 puts only the items that are in there. Okay, and so there's our stat plot. Okay, so you can see this graph I've made. It looks kind of strange, but I mean, it gives us an idea of what we're looking at. If you want to blow it up, you can change the window. The window goes from, it's too low, so let's not start from 0. Let's see, it says it's starting from a minimum of minus 34, but the maximum is the minimum on this is 173. So let's see what we can do here. Minimum, y minimum 170, 200. Let's see what that looks like. Zoom graph. Now we can see a little bit of it. We can see that graph looks a little funny, but you can see that the ratio is not 1-to-1. It's close, but if it was 1-to-1, it would be an even line or a straight line. Okay, but it's not a straight line, so it's all good. But you can see that there's a definite correlation between the height and the arm span. Arm span is bigger than the height almost in every situation. 1 inch here, 2 inches here, 3 inches, 5 inches, 4 inches, 3 inches. This one's less, 5, the same, 4 inches. So you get an idea that in that swim club, most of the swimmers, or 9 out of 10 of the best swimmers, have longer arm spans than they do height. So use what you know about this situation in the data to find a function model for this data set. Is there a possible proportion of arm span to height? What is it, and how do we use it? So let's look at this. The possible is the ratio of arm span to height. We just talked about that. We can use it to find a linear function to closely describe the function for arm span versus height. And that's what we did in this last slide, or not in the last slide, but in the calculator. We're looking at a function, and we can do a regression on it if we want to, and we'll talk about that here in the slideshow. Okay, present. And let's move on. So what are we looking at? We look at each individual data value and each variable, height versus arm span, and to calculate the ratio for each, we'll look at the average and use it to create a function to describe this relationship. So if we look at this ratio over here, we're going to divide the arm span by the height, and we'll get a ratio. And as you can see, every single one except this one right here is more than 1 or more. And the average is about 1.014. So the function would be whatever that common ratio is, that average ratio, we can call it a common ratio, multiplied by x. So if the x factor is the height, we multiply x by 1.014, and in the averages, we'll get the arm span. So if we go to stat edit, we'll place both columns in. After putting the column, push the second 0 and scroll down to diagnostic on, and use line reg to determine R, the correlation ratio. And how does the regression equation given by your calculator compare to the function you found in the last slide? Now let's look at this. So we're going to turn diagnostic on. Let's follow the directions. Stat edit. We entered all that stuff already. Push second 0, and we're going to scroll down to diagnostic on. So we're going to hit diagnostic on, enter, and turn it on. Now it's on. Now we can do a line reg to determine R. What is line reg? Okay, it's linear regression. So how do we do that? Let's see. Stat, calc, scroll down to linear regression. Okay, and enter. We're going to use the two columns, L1 and L2, that we entered, and we'll calculate it, and that gives us all of our information. Now notice we're given a little bit more information. Y equals AX plus B. A is 1.02. It's a little different when we got early, 1.014, but it's still close. and B is -1. It's not 0. But we're looking at the R factor, okay? We can determine the R factor, the closest it is to 1, or in the case of a negatively correlated, -1 for R, it can tell us how correlated they are, okay? So let's look at that, see what that means. In this case, we see this. Let's use this again to determine how to use this. We're going to turn diagnostics on for TI-84 plus. We just did that. You're going to go to second 0 right here, which is catalog. You're pulling up a catalog of all the applications on the calculator, and you'll scroll down till you get to diagnostics on. I've already done it, so I'm not going to do it again. So we're going to go to stat edit, stat, and edit is already there, defaults. I can hit 1 or I can hit enter and get the same answer. So 1 will give me edit, and I'm going to clear these, okay? So I'm going to move up, clear, enter, and then I'm going to move up to this one, clear and enter, and then I'm going to enter the new values that we have here. So X in L1, we'll put -2, the first value, -1, oh, I put, sorry, you have to use this negative here, I apologize, -1, enter, oh, nope, that's -2, I'm making all kinds of mistakes here, stat, enter, -2, enter, then the next one is -1, then 0, then 1, then 2, and then we'll scroll over to L2 and we'll put in those numbers, -4, -2, 0, 2, and 4. All right, so let's see what it tells us to do next. It says go to stat and then calc menu up at the top, and finally select 4 line reg and press enter. So calc, which is right, stat, scroll over 1 to calc right here, and then scroll down to 4 or hit the number 4, works the same, line reg, and it's going to use those values that we put in L1 and L2, and we'll calculate, and it pulls this up. So our line function is y equals ax plus b. We recognize that as the slope-intercept form because a is the slope and b is the intercept. So the slope is 2 and the intercept is 0. So it goes to the origin, and notice that the correlation R value is 1. It says that here, calculating R value. The closer R value is to 1, absolute value 1, the more highly correlated the data set is to our linear relationship. The closer the value is to 0, the less correlated the data set is. So, all right, let's move on. Keep going here. Consider each scatter plot below. Match each R value to each scatter plot. Now remember, the closer it is to 1, the more correlated it is. And the closer it is to 0, the less correlated. Well, let's look at this first picture. It's obviously that there's no general direction of the line, is there? Not at all. It's not correlated at all. And the only R value that's not close to 1 is this middle one. So we would venture to say, I would venture to say that that is probably 0.33. Notice there's one negative and one positive, and both numbers are very similar. And we have one with a positive slope and one with a negative slope. And you guessed it, the number that has a negative R value also has a negative slope. So let's look at the answers. I actually don't notice that they have answers. So does a strong correlation indicate cause and effect relationship between variables? So let's think about this. Would the relationship we discovered that exists between arm span and height help a coach find Olympic swimmers just by looking for those variables in people? Now, I would venture to say that they look for it, but that doesn't necessarily mean that makes them Olympic swimmers. It gives them more of a potential to be Olympic swimmers. Okay, now I want you to consider this. Society deems successful today. Just because you don't fit the image that society has molded as the perfect success story should never mean you cannot be successful. I find success in the little bitty things that I do in my life. For instance, the little tiny house I'm building. I'm doing that on my own. I have no formal construction experience. I have no formal plumbing experience. I have no formal electricity or electrician experience. I'm doing this all on my own, just from what I've learned on my own and not killing myself, and YouTube. So I'm trying to capture all those memories on my YouTube channel. I'm not doing a real good job of it, but I'm trying to. So if you're interested in that, you can check out my personal channel. I don't really care if you do or not. But that is my success story. And it may not be what you consider a success story. You may think material riches and a nice house in the city is good, but me, I just want someplace out in the country where I can grow my own food and society can leave me alone. Sometimes that's just really what people need. And you may find that the older you get, and you will, I promise this will cross your mind sometime in the future, that the older you get, the less you like to be around a lot of people, and the more you like to be around people you love and the people that love you. And that is what I consider a real success story, is to be able to surround yourself with people that love you and that you love. And when you find those people, they don't necessarily have to have the same viewpoints in life, but that is what I consider successful. So in the meantime, there is a lesson I would suggest that you go out and get that done as soon as possible. Don't get behind, because when you do, that puts you in a pickle at the end of the marking period, and I hate for you to be in that situation. So get on it right away. In the meantime, y'all be blessed and be a blessing.